Hard to believe. So again, in the past, the phraseology would have been, here's a sequence, find the sum of the first however many 58 terms or whatever of the series. So the language changes pretty significantly here today. So when you see a sigma like this, it's going to look like this. It's a 9 on the top. N equals 4 on the bottom. Yeah. Did I write it too small? Oh. So you're going to find yourself kind of thinking in the same sort of terms today. It's very formula heavy. What I did when I was thinking about how to explain this to you today was I conjured up two examples of arithmetic and two examples of geometric. And I wanted to show you sort of why the formula is important. So in this first example, once you understand what this language means, you'll understand that you really don't technically need a formula to do this one. But then you'll see in the second example why we definitely want to use the formula. So in this one, does anyone want to try to make meaning of this weird new symbol, this language?
Is it like the difference in the terms, something like that?
So this is this is what it means. And welcome to the new language. It means that we're going to start at the fourth term of the sequence, and we're going to stop at the ninth term of the sequence, and we're going to find the values of all of the terms being created or coming into existence by evaluating the expression in the yellow box. So we can see that it's an arithmetic sequence in the yellow box. And you may not know this, but the sequence is going down by 2 each time. It's like back in algebra 1. You remember like the slope of a line, y equals mx plus b. So you can see that it's arithmetic because it goes -2, -2, -2. And what we're going to do is we're going to find the fourth term. Sorry for this, and then the fifth and the sixth and the seventh and the eighth and the ninth, and we're going to manually sum them together. And that's what the language means. So the bottom number, when it says n equals 4, means start here. The top number says stop here. And the sigma is the notation that says find the sum of all of the terms that start here and stop here. Got it?
Issues.
Don't. Sorry. Just give it a good farmer blow. I can say that on recording, right? Farmer blow.
Yeah.
I know. Hold on a sec. Silly. So sorry for the incoming manual labor, but this will give you some. I wasn't going to do this, and then I watched a video and thought I liked the way the video rang with me, so I thought this would ring good with you guys too. So we're going to start with the fourth term. So we're going to start by saying a sub 4. Because that's what the sigma notation at the bottom, it says start at 4. So we're going to find the fourth term. And in case you didn't derive this yet from what I said, you're simply going to keep doing input output. So you're going to take the number 4 and stick it right there. We can do this math in our heads. What's -2 times 4? What's -8 plus 5? So we can say that the fourth term of this mystery sequence or series is -3. Okay. Now we're going to travel on, and this is totally doable because we don't have to go very far. We're going to travel on and find the fifth term. And it's going to be the same thing. We're going to just take the expression in the yellow box and we're going to put 5. What's -2 times 5? And -10 plus 5 is -5. Then we're going to find the sixth term. Scoot this up just a little bit. Same, third verse, same as the first. Put in a 6. What do you get? Right, -12, and then you got to add 5. Right. And I said this earlier, and I think some of you looked at me like I was crazy, but maybe now you can see what I was talking about with the whole slope reference. You can see now plainly with your own eyes that the sequence is going down by 2, right? So that comes from right here. That's what I meant when I said it's obviously arithmetic. So the slope of this is causing this to happen. So from here, you could continue to do it manually, or you could just kind of jump ahead. What's a sub 7? -9. What's a sub 8? -11. And what's going to be a sub 9? Good. Do you have any questions so far? So this is how you would find the sum of a partial sum of a series, um, in a manageable situation like this. You'll see in the next example, there's no way we would want to do this, but when there's only this many, it's not a big deal, right? So if we went just old school mode on this, then we could just quite literally add the numbers together. So if you take the values of the sequence, these, and you add them together, what do you get?
Something negative.
Mhm. Nice job. We get negative 48. Let me pause this. The way we do this the other way. So that's how you approach a partial sum sigma notation. If it's manageable, like if anyone ever gives you like n equals 4 to 7, you have to almost ask yourself, is it quicker just to find terms 4, 5, 6, 7 and add them together like this? So today we're going to do a new version of the arithmetic formula. You're going to want this formula. Everything okay?
Okay.
I'm going to change colors and I'm going to write this in yellow, and I really want you guys to write this down. So in a world where you're allowed to use notes or note cards or a page of notes or however you do that, you've now got four formulas at your disposal. If you're keeping score, you should have now two formulas for arithmetic and two for geometric. This is a really, really handy dandy formula to have laying around. And honestly, you could make it out of the other one. It's just really weird. But the other version of an arithmetic formula that you have is really good when you see a sequence from a different perspective. And you start to learn like when is it good to use one and when is it good to use the other. For sigma notation problems, you're going to see that we definitely want to use this. So I'm going to label this for you and I'll tell you kind of how to put this in your notes. This will come in handy. You want to use this formula when you're doing the sigma notation problems, and it's arithmetic. Trust me on this one. So like, for example, the problem that we just worked on the board is clearly given in sigma notation. It's clearly arithmetic. So let's take a look at how our problem that we just did could be solved using the formula instead of old school, grind it out kind of thing. So everybody got that written down? Okay, so I'm going to scroll back up a little bit. Let's talk about the cast of characters. And so this is where I'm pretty certain that this will be a part that you maybe want explained again. So when we look at what we just did, can you guys tell me what? And again, you're always very open with me, but ask if this doesn't make sense. Can you guys tell me based on what we just did, what n is going to be? No, no, no.
Your term number.
Would it be negative 2n?
Nope. No one said it yet. Nope. Let me ask you this in a different language. How many terms did we sum? That's what n is. So in this particular example, we can all agree that n is 6. The one we just did, you could literally look at your notes or at the TV right now, and you can see that there are 1, 2, 3, 4, 5, 6, correct? Those of you that said 5 early on, I totally get it. I know exactly where you got that from. But what you failed to consider, and I don't remember who you were who said that, but if you do 9 minus 4, I assume that's where you got 5. You forgot that you have to add 1. So like if you were counting things, let's say you were standing on like the first platform and you were going to walk to the 10th. Like that example is not going to go well. Yes, you're standing on the initial, or thank you for amending my ghetto example, right? You're standing on the initial, like the 0th. And so when you count, you have to add 1 when you count the physical number of things. So like if someone says, how many numbers are there from 9 to 4? It's really easy to say 5. But the fact of the matter is that 4 counts as 1. So you go 4, 5, 6, 7, 8, 9. And you're like, holy crap, there's 6 of them. And that's because you have to count the beginning. So this is a trick you're going to use on almost every problem is you're going to take the top number of your sigma and the bottom number, and you are going to subtract them, but you're always going to need to remember to add one. And that accounts for the beginning, okay? So n in this case is 6. What is a sub 1?
Negative.
It's -3, and that's going to freak you out a little bit because you're gonna say, no way, that's a bald-faced lie. There's no way because the a sub 4 is -3. Well, what we're going to do is we're going to have to shift our thinking a little bit, and we're actually going to kind of reshape how we look at this, and we're going to now think of this. I'm going to put a box around it for you. We're going to now think of this as a little miniature sequence where the first term is actually -3. And this one, we currently know him as the 9th term, right? He's not. What is he? He's the 6th term. So going forward, when we start thinking about how can I apply this to the formula, I need to think of the terms not as what maybe they are on the surface, but I need to rename this first one and say, you're actually my new a sub 1. And you're actually not that I care, but you're a sub 2 and so on and so forth, leading us to this one who's actually a sub 6. Okay. This will make more sense, I think, if we skip the old school way and we just go right in. I think like the next example, it'll lock in for you. So what's a sub n going to be? This is a tough question. Another way to say a sub n is like, what's the last term in the part that I care about? So when we think about this math problem that we're doing right now, what's the last term value in the part that we actually give of our snapshot of it? Who's last? -13 is correct. So a sub n is another way to say that is for your notes, we'll call that the last term. And in this case, it's obviously -13. So that concludes the cast of characters. And like if I can find all of those, which I can 100% of the time, then I can plug them in and put in my calculator, hit enter, and I'm done. So let's take a quick moment and see what this actually looks like. Okay. So if we plug those numbers in and we math it, what it's going to look like now is we're going to say it like this. We're going to say the sum of these 6 terms is equal to 6, since there's 6 of them, times what 2 numbers added together? -3 and -13. And then we're going to divide by 2. So help me with my math. If we add the parentheses together, what's -3 plus -13? -16. So now what we're dealing with is 6 times -16 divided by 2. And what's 6 times -16? And what is -96 divided by 2?
No, that's wrong.
-48.
-48, which I don't know if we ever actually came to consensus on this. Did we ever actually finish adding all these numbers up? Did I write it down at some point and then erase it? Good. So we got the same answer when we did it old school. Remember how we just added them up and got -48? Well, we just applied the formula and also got -48. And I do that just so you can kind of see both sides. For this next example, we are not going to try to do this manually, and you'll know why quickly. So that's a couple different approaches to how you can do a sigma arithmetic sum. So let's do another one. I hope you feel better. That might have been a little confusing. I hope you feel better after this one. Unless you already feel great, then that's wonderful. So we're going to, again, have this. And we are going to go from n equals 5 to 61. So before we begin, I need to ask this. You okay over there? Did I? Okay, good. How many terms are in our little snapshot? You got it. Good job. So don't worry if that doesn't make sense. It will in about 14 seconds. Here it goes. This sequence that we're looking at goes from the 61st term down to the 5th. You want to know how far it is between them? You subtract. What is 61 minus 5? 56. But like we discussed, because you have to count the initial step, you have to add 1. You're going to want to keep that understanding very handy. So there are 57 terms in the snapshot that we're about to work with. It's not even a bad idea right now just to go off here to the side and just jot it down just while you're thinking of it and say n is going to equal 57. That's going to be super useful knowledge. Now, you would ask, well, what are we summing? Well, we're going to sum this. Arithmetic, you can see it. Well, what would my terms change by if I wrote them all out? They'd go up by twos, right? So this one wouldn't be unmanageably annoying, but it would still suck. So let's practice with our formula. So knowing the cast of characters, when you look at the little formula that I gave you, there are some guys that you need. Who's the first guy that we really need to know? We need to know M. So I'll just write it down here since I've already started. N is 57. And who is A sub 1? No. Yes. And again, it could be very confusing because you cry like witchcraft. No way, this can't be true. But the bottom line is this: if we started writing out the terms of this snapshot, we would put 5 in first, right? Right here where the purple arrow is pointing, you would put a 5. So that's 2 times 5 is 10 plus 3 is 13. But as far as we're concerned with the portion of the problem that we are zooming in on and looking at, that is our quote unquote first term. So the first term that we care about is 13. Got it? What is A sub n? And remember, right. Yes. So specifically in this case, A sub 61 is what we're interested in, which in the formula is going to say A sub n, but it's the last term. And so for us, that just means go to where the purple arrow is and put in a 61. And what's 2 times 161? 122 plus 3 is 125. And just like that, we've got our cast of characters all laid out. The only thing that would confuse me as a kid would be, why did you call A sub 1 13 when that's really A sub 5? I get it. Overall in the sequence, yeah, it's the 5th term, but the part that we're zooming in on and looking at, it's our first that we care about, right? So having said that, going back to the formula that I just gave you, all we're going to need to type into our calculator now is n, so 57 times, what goes after that? Right, and you're just ahead of me. I don't want to skip steps here. So what goes right here? Thank you. And I get it, but I don't want to do that quite yet. And what goes after that? The 125. That's my last term. And then I divide that by 2. Did that feel a little better maybe than the first one? The first one comes at you like a little bit of a weird thing. This one hopefully felt pretty good. And then you're just going to type into your calculator 57 times 138. You're going to hit enter. You're going to hit divided by 2. What did you get? That is correct. So what that means for us is that the sum of the terms of not the first 57, in this particular sequence, the sum of the 5th term through the 61st term would be 3,933. That is how you use or understand or work the sigma notation for arithmetic. Are you okay with that? All right, let's talk about geometric. For the geometric, we are going to be using, you already have this formula, by the way, but we're going to stick with one. We're going to just pick it and stick with it. So the one you're going to be using today is here. And again, you already have this, but it's just worth, I think, adding into your notes that this is the one I'm going to use when I'm working in this particular notation. And I don't know if what I just said makes any sense. I mean, in the grand scheme, you really theoretically could use the other one, but maybe, I think we do better as a group collectively if we're just all on the same page. So yeah, let's stick with this guy. So we have a cast of characters that again involves A sub 1. Who's A sub 1? Just generally speaking. The first term. What's R? The ratio between 2 terms, right? So if the term goes times 2, then R would be 2. If the term's going down, dividing by 2, then R would be a half. What's N going to be in our case?
Number
the number again of the terms of the sequence that we're summing together. So we understand the cast of characters. The question now is how do we pry them out of what we have? So for this one, again, I have two examples and I'll try to be quicker on this first one for you. That one dragged on way too long, that first one. So here is our, you see me draw these really slow. I have a tendency to make them look, that's pretty bad. So anyways, if it seems like I'm being really meticulous, it's because I'm trying to unsuck those sigma notations. So for this one, we're going to go from n equals 1 to 5. And we are going to be summing the terms of this. Good. And we can tell it's geometric. Like we've had enough experience with this to just know that that fits the geometric sort of pattern. Could you look right at it, just square straight away and tell me what R is?
5.
R is 4/5. And it was pretty big of you to jump like that, but let's just call it 0.8. I love what you did, but let's just all agree that R is always going to be located right here at the base of the exponent. So we can agree for this problem that R is equal to 0.8. That's where you'll always find it in a geometric sort of situation is right there. So let's old school this guy just like we did before. And I swear I will try to be fast. So come along for the ride with me. Here we go. We're going to find a sub 1. And all that simply means all it's ever meant before is put 1 in place of n. If you put 1 up here where this purple arrow is pointing, just this one, I don't need a calculator. What's 1 minus 1? What's 0.8 to the 0? 1, meaningless. So the first term is 5,000. Let's find a sub 2. I can save you the time if you want, because I already worked all these out. So a sub 2 is 4,000. Do you trust me? Oh, don't answer that. Yeah. And then a sub 3. All we're doing is effectively multiplying each time by 80%. We're taking 4/5 of what we had before. So it's going to drop to 3,200. A sub 4 dropped to 2,560. And then a sub 5 is going to drop to 2048. I don't want to slight you of an education. Does anyone have any questions as to where those numbers would have come from? Putting 1, 2, 3, 4, 5 in place of n and typing it into your calculator. Hayden, you good? Okay, good. So if I wanted to know the sum of the first 5 terms of this sequence, then I could just add together the numbers that I have. And I don't know if you've worked on that or not, but the answer, I'll just write it. I'm gonna use yellow and I'm gonna write it right down here is 16,808. That was a lot quicker than last time. Any complaints or issues with that? All right, let's look at how we can apply the formula to this instead of writing it out. Because again, there are going to be situations where doing this is not even really within reason. Writing out all the terms would be nuts. So let's go through our cast of characters. We already know who R is, 0.8. Can you guys tell me, too bad I just erased it, what A sub 1 is? Yeah, we know that one. It's 5 grand. And then can you tell me what's the only other thing that I need? I just need n, right? What's n? In this case, what's n? In every case, what is n? I shouldn't say that. What always does n mean? The number of terms that we just added together, and how many were there?
5.
There were 5. And I'm telling you this again, this formula will never fail you. You need this one. Keep it in your back pocket. Take the top number on the sigma, subtract the bottom. What's 5 minus 1? 4, and then always add 1. Good. So there are 5 terms in the sequence, in the little partial thing that we just added together. So we have our cast of characters, if I'm not mistaken. So we can now say this. We can now say that for this problem, the sum of these 5 terms is equal to, here we go. What are we going to put in place of a, let me scroll a little bit because it's getting a little blocked there. Right, we're going to put 5,000 minus 5,000 times 0.8 to the power of 5, all divided by 1 minus 0.8, which is everyone okay if I just write 0.2? Save us a little bit of calculation later on. So the way I would type this in, I feel like I go through this a lot with you, is I'm just a play it safe guy. Cooper and I had this talk yesterday. He likes to just hit enter once. So the way I do it is I type in the top and I just hit enter. And then with that number on my screen, I hit divided by, I don't care. At the end of the day, we're going to put them into our calculators like a little bit differently than each other, like as far as how many steps it takes. But in the end, every one of you here within the next 30 seconds or so should be able to like nod your head at me and say, I got it. I got 16,808. Good.
No. Within 5,000 minus 5,000
You didn't hit enter there, did you? Oh, thank God. I'm sorry I even asked that. That was rude of me even to ask. I apologize.
times 0.8 to the fifth.
Yep. It's not going to work unless you put 16,808.
Yeah, 1,608.
You should divide by 1 minus R, right? And don't we all agree that R is 0.8? It shouldn't be 16,808, should it? Or should it? Did you guys get this?
Yeah, I got.
You did.
Yeah.
I got
Okay.
16,000.
I did it
Good.
again.
So it works now?
I just put it in.
Yeah.
Or something like
I second guessed what I had done there and I was like, what is happening? We're good. Is everyone okay now? Oh, can we press on?
Yeah.
Good. So that's how you basically apply the formula. And I have one more example of this, and then I'm going to get out of the way. As always, I don't know. I have no concept. Like, and it took one. This will wind up being a 40-minute lesson. So tomorrow, obviously, will have to be a work day. Did I say you'd have a quiz this week?
Yeah.
Did I say that out loud? Okay, it'll probably wind up being potentially a lie because if tomorrow's a work day, then I'll probably have to move the quiz to like Monday or Tuesday. Are you okay with that? Okay. Yeah, I had to call an audible when I realized, oh snap, I forgot we never came back to Sigma. So I think we're doing really well with the Sigma thing, by the way. We've really made it through this pretty strong. Doing okay over there? Just getting used to it now?
I'm fine.
This is
Smiling at Ada.
Because he said they're like about to burst out laughing. It's
I'm not.
funny.
You
said that, like-
you're gonna be like,
Dude, your lips are quivering. What are you talking about?
No, that was rough.
That's a hard one. Sorry, I'm just gonna leave it. I don't care. I'm not ashamed of that. So trying to be consistent with the theme here, and that is like, okay, we'll give you one that you theoretically could do manually, and then one that you just wouldn't want to, like this one. So we're going to be summing the terms from 1 to 28. The first term to the 28th term. And then, of course, the value of the sequence will be determined by this. I don't want to do this the other way. Like, I don't want to go and find 28 different answers and then like, oh, no way. So in a case like this, generally we're going to round probably to the nearest whole number because what's going to wind up happening is like, if you think about the sequence, we're taking 91% of every term to find the next guy. And eventually you're going to pretty quickly dip into decimals. And so when you get the answer for this, the directions will, I think, say like round to the nearest whatever. So in this one, we'll just go to the nearest whole number or integer, whatever. Okay. So let's talk about our cast of characters. The characters that we need are a sub 1. So, I mean, sort of rock star, sort of life hack. Go through your cast of characters and write them all down. We've done this before in other contexts. It's always a good idea to fill in your characters. Can you guys tell me who a sub 1 is? It is. And listen, I was worried about that because on the last example, a sub 1 was sitting right here. Why is a sub 1 not 400? What changed?
There's nothing happening in your exponent.
It's this. Good job, Cooper. In the last problem, if you look back at it, we had n minus 1. So that was effectively wiping the first term out as we saw it. This one, you got to be really careful. So when you put 1 in place of n up here where this little purple arrow is pointing, yeah, the first term is not 400 like we wish it was. It's actually what Coop said. It's 364. And to find that, you just type in your calculator 400 times 0.91. You don't need an exponent if it's 1. That's silly. The other character that we need is R. And R is visible. Who's R? 0.91. And the only other character we need, and this, we just be faithful about this. This will never fail you. What is it? 28. N is 28. And it's pretty easy when your first number is 1. Like if the first number is 1, then the top number is N. But you got to be careful when things start getting a little crazy and the bottom number changes. So always remember your subtract plus 1 formula. But there they are. That's all the characters that you need. And then we're just going to faithfully plug them in. So our work step is going to say S sub 28. We're communicating to the world. We're finding the sum of 28 terms, specific terms of this sequence. What goes first on the top?
364.
364. So that's A sub 1 minus A sub 1 times 0.91 to the power of 28 divided by, it's not 2. 2 was for the arithmetic, 0.09. And I might, as a student, be inclined to say, where did you get that? And I would just remind you that the formula here calls for 1 minus R. And if R is 91 cents, $1 minus 91 cents is 9 cents. So that's where that came from. And that's, I mean, the teacher part of it is done. Now it's just up to you to type it in correctly. So I never wrote the answer to this one. So let me work it along with you. Maybe I did work it. Yeah, that is, I forgot to just write it down, but I did work it. So the answer to this is 3,756. And that was 3,756.029434, but rounding to the nearest whole number produces that. Longer than I wished for, but done. Let's work for 5 minutes. Get the bust out your old Chromebooks and let's see if we can knock out one. That's our goal. 1 problem, maybe 2, and then we'll leave in peace and we'll work tomorrow.